All right. So 8.4 is taking the different parts of a circle. Or are we finding all the different parts of a circle? Okay. Now we've talked about a circle before. I know you guys have taken the areas of circles before. We've got that formula up there. Area of circle equals pi times the radius squared. So we will be finding the area of a circle. The other two areas we're going to be finding are, let me draw it over here. We're going to find the area of kind of the donut shape. We call this an annulus. Okay, but it's the area that's in between a small circle and a big circle. Okay. We're going to be finding that area. And the third one we're finding is the area of a pie-shaped piece, which we call a sector. Okay. Now, what makes it a little bit harder than how we found areas before with our circles is a lot of our areas of circles, we want to find exact areas. Okay. Now, when you're multiplying things times pi, they're not exact anymore because pi is one of those numbers that goes on forever. Okay, it's an irrational number. There's no way to write it as a fraction. Okay, we have a whole number on the top and the bottom of the fraction. So it's going to be a decimal that goes on forever. So the way that we actually write our answer is in terms of pi. It's similar to how we leave our simplified radical answers as radicals, rather than taking the square root of 2, which gives us a decimal that goes on forever. We leave it as radical 2. So it's similar to that. Okay, so bear with me as we get started with the process of writing it as a exact answer, but you'll notice it's actually not too bad. It's taking one step away. You're just not multiplying times pi. Okay, and then you leave your number in front. All right, so we're going to go through a couple examples of finding the area of a circle, finding the exact area of a circle, and I'm going to show you the two different ways that you can leave your answer in an exact format. Okay, so we have a circle, and we're given the radius. The radius is 3 radical 2. Sorry, it's a little small for those of you back row. You might not be able to see that. That's 3 radical 2. So the area of our circle is pi times the radius squared. Well, our radius is 3 radical 2, so area equals pi times 3 radical 2 squared. Now, if they're asking us to find the area of the circle and round to the nearest tenth, then I would say plug this in your calculator and then round it to the nearest tenth. But they're not. They're saying find the exact area. So what I'm going to do is I'm going to leave pi alone. Okay, I'm going to leave pi alone. And I'm going to figure out what 3 radical 2 squared is, and I'm going to put that number in front of pi. Okay, so 3 radical 2 squared. We could do this in our head, or you could plug it in the calculator. Either way would work. Just make sure if you use a calculator, you put it in parentheses. 3 squared is 9. Radical 2 squared is 2. And 9 times 2 is 18. That's our exact answer, 18 pi. Okay. Now, it's 18 times 3.1415. It's, yes, if we want to figure out what it is rounded, about what the answer is, we could multiply it times pi and round it. But exact would be 18 pi. This one's not too bad. They get a little more difficult when you have fractions. And the next couple examples do have some fractions, so you can see how those look. Okay, so there's the first one. Second one. All right, now in this one, they didn't give us, we weren't given the radius. And you're not always given the radius, just like with all the other areas we found. Sometimes you have to find the different pieces of the area. So in order to find our radius, it looks like what we're going to have to do here is we're given a right triangle. I'm going to need to find the diameter and then divide that in half so that I have a radius. Okay, so let's go ahead and use the Pythagorean theorem to find our diameter length. We'll make this A, B, and C. So 3 squared plus 7 squared equals C squared. 9 plus 49 equals C squared. 8 equals C squared. Find C, I take the square root. All right. Now I know what I'm doing, and you guys probably do too, but I don't like the way that looks because I know radical 58 doesn't reduce. So I got a big radical. That's the length. Okay. That's the length from here to here, a diameter. So if I want a radius, I would need to take this length and divide it in half. It's green here. So dividing that in half, our radius is going to be radical 58 over 2. Okay. That's our radius length. And again, I'm leaving them in exact terms because if I take the square root of 58, it becomes a rounded answer. So I'm leaving them exact. Well, let's use that radius to find the area of our circle. So pi times the radius squared. All right, so when we square that, square root of 58 equals 58. The square root of 2 is 4. Leave pi on the outside here. Now 58/4 does reduce. Unfortunately, 4 doesn't go equally into 58, but I know that that does reduce to 29 over 2. This is one way that we could write our answer. 29 over 2 pi. The other way you can write it, if I want to put pi within my fraction, because pi is the same thing as saying pi over 1. So you can multiply straight across and get 29 pi over 2. So you'll see it written both ways. Somebody last class asked, can you write your answer as 14.5 pi? That is equivalent, okay? You don't often see them written as decimals, okay? But it is correct, okay? If you were to write 14.5 pi, I would mark it correct. That's exact, it's an exact answer and it's correct. More often than not, things are left in fraction form, okay? More often than not, you'll see things left in fraction form. Like one of these two ways I have circled down here. I think the reason why we leave it in fraction form is because if it's in fraction form, whether it, in this case, it does, you can take 29 divided by 2 and it equals a fraction, or it equals a decimal that is a finite decimal, okay, 0.5, it stops there. If that was 29 divided by 3, all of a sudden we'd have a decimal that goes on forever, right? And we could write it with the line over the repeated part, but it just looks a little cleaner when you write it as a fraction. So if we're consistent with the fraction, then it makes it a little bit easier. All right, an annulus. An annulus is a donut-shaped 2D figure with a circle inside another circle. The annulus is the part between the outer circle and the inner circle. So it's the donut part. Now, what is nice about an annulus is we're using formulas we already are using. Okay? You have two circles, a big circle and a little circle. If you want to find the area in between the two, you just take the area of the whole big circle and subtract the little part out. And that's what we're going to do. We're going to take the area of the whole circle and then subtract the middle out. Not gonna lie, it makes me think of like donut holes. I'm craving one right now. But formula is pretty easy. I'll wait for you guys. All right, so it's pi r squared. Okay, pi r squared. Now, looking at this diagram, I read this as this length is 3, and then from here to here is 7. If we wanted this to be 7, then we should probably write that 7 in a different place and maybe even mark the put a little bracket to show that it's 7. So in this case, I would say our small circle's radius is 3, and the big circle's radius is 10. Okay, 3 plus 7. So let's find the area of the annulus, area between the circles. So we got pi r squared of our outer circle. So pi times 10 squared minus pi r squared of our inner circle, which has a radius of 3. So pi times 3 squared. Right? If we want our answer exact, then we're not going to multiply times pi. We're going to leave pi alone. So 100 squared, or 10 squared is 100. So that'll be 100 pi. And 3 squared is 9. So minus 9 pi. Now this is just like, treat this just like it was like x, like 100x minus 9x would be 91x. It's the same idea here. 100 pi minus 9 pi is 91 pi. So the area of our annulus for this diagram would be 91 pi. Okay, let's do one more annulus example. Here we have one where it says the diameter of the big circle is 18, and the diameter of the small circle is 6. So that makes the radius of our big circle would be half of 18, which is 9. And the radius of our small circle is half of 6, because it says the diameter of the small circle is 6, so half of that is 3. So we got, looks like we're going to do area equals pi times 9 squared minus pi times 3 squared to the 81. That's going to be 9. 81 minus 9 is 72. Again, I think the annulus one, if you can find the area of circles, finding the area of the annulus is pretty straightforward. Okay. I think you guys are going to be okay on that one. All right, our last thing that we're taking the area of, sector. A sector is a pie-shaped piece of the circle defined by 2 radii, the arc, and the interior. Now, we haven't really defined what an arc is, right? Which is what we do here on the bottom. It says an arc is a part of the circle, including 2 endpoints and all the points on the circle between those endpoints. So our 2 endpoints are point D and point E, and then all the points in between them on the circle. This is an arc. So those, the two radius lengths here, AE and AD, right, and the arc make up the boundaries of our sector. Now there's a relationship between the sector and the circle as a whole. You guys okay if I move on? I see some people writing. Oh, wait a second. All right. So a couple of relationships our arcs have with our circle, okay? They have a length and a degree measure. So they have a length, like if I were to take this distance from E to D, you can't see D, but that's point D right there. If I were to take that, let's say cut it off the circle and stretch it out straight, I could measure that and it would have a length, all right? But it also has a degree measure, and that degree measure is equal to the angle that's made between angle D, A, and E. Okay, this angle is always equal to the arc angle measure. Okay, and we call this the central angle because it's made from the center of the circle. Right? So the degree measure of that is always equal. That's the part that we're going to need to find the area of a sector. We need to know that central angle that's equal to the sector. And the reason why we need to know that is because we need to know what portion of the whole circle the sector is taking up. Okay? Because if we know the area of the whole circle, and we know, let's say the sector is a 90-degree angle, which is a quarter of the circle, then we can take 1/4 of the area of the full circle to get our area of our sector. So what we're going to be doing is we're going to be comparing our sector degree measure to 360 degrees and multiplying that times the area of the circle to get our answer. And I think what makes it hard is not plugging the values in. The hard part is you're going to have some fractions that you have to make sure are reduced. Okay. We'll have two examples here of sectors. Actually, maybe only one, I can't remember. We'll see in a second. All right, so here is the area of our sector. Here is the formula. Right? Area of a sector is the arc degree measure over 360 degrees times pi r squared. So again, it's the portion of the full circle, which is that's the arc degree over 360, times the area of the circle, pi r squared. We'll do two examples. So what we're going to need to plug in, we need to know the arc degree and we need to know the radius. If we know those two things, we can find the area of our sector. All right, so here is a circle with a sector, a shaded sector here, where the arc degree measure is 100 degrees. That means the central angle is 100 as well. So let's plug in what we know here to get our area. So it's the arc degree, so 100 over 360 times pi times the radius, which in this case is 8 squared. All right. Now we want, okay, I'm gonna end up having to reduce two fractions here. You could do it and only reduce one. my brain tells me I need to reduce the fraction first, so it makes the math easier. Like 100 over 360 reduces. And if you guys have a red calculator or a graphic calculator like this, when you plug the fraction in and hit enter, it'll actually reduce the fraction for you. I'm sure there's tools that do this online as well. In fact, Google probably does it for you if you just ask, or Siri would. So if I type in this fraction, 100 over 360, 5/18. So this first fraction here reduces to 5/18, and 8 squared is 64. Okay. Now, I want this to be in as simplest form as possible. I want it to be exact still. So I'm going to leave pi alone. I'm going to multiply 5/18 times 64, right? Now, 5 times 64 is 320. So that would be 320 over 18 times 5. That fraction reduces again. I know it does, but it only reduces, I think it only reduces in half. So I think it just becomes 160 over 9 pi, or 160 pi over 9. If those would be the ways we could write the answer exact. Okay. So the hard part about this one is writing it as an exact answer. If I was given this problem and said, and you guys were told, find the area of the sector, round the answer to the nearest tenth, I could take this first thing that we wrote down up here, I could plug this in my calculator and round to the nearest tenth. Okay, I would want to multiply times 5, but I can plug it in as, let's see, 100 over 360 times pi times 8 squared, and I get 55.85, which rounds up to 55.9. So these answers down here are about 55.9. Okay. So again, if you're allowed to give your answer as a rounded decimal, it's a lot less work. You just have to find the two values to plug in up here and use your calculator. If they do require you to find an exact answer, then make sure you're getting your reduced fractions or your reduced numbers that go in front of pi. Okay. All right, we'll do one more. All right, so in this one, it says find the area of the sector. Talking about this area right here. All right, we got our degree measure, that's 130. So 130 over 360 times pi times 5 squared. All right, let's see, 130 over 360. That's just going to end up being 13 over 36, but let's double check. Yep, 13 over 36. Pi squared is 25. All right, let's combine that. 13 times 25 is 325. Let's see if 325 over 36 reduces. It's not looking promising. Nope. 325 over 36 pi, or 325 pi over 36. The reason why I'm writing it two different ways is because leaving it as a fraction, you could see it either way. I would mark you correct if you wrote either one of those ones. Okay. All right. You guys have any questions? Circles, annulus, and sectors, okay? There should be an assignment already for you guys in Google Classroom. It should be the first thing in your stream right now. It's an Edge Elastic assignment. It covers these three things. Recommend having, there might be enough room on there if you guys are good with the writing tool. I'm not a fan of the Edge Elastic writing tool, but might be a good idea to have a sheet of paper out so you guys can write down the equations that you need in a calculator.